How you doing today? Sorry, I'm with last minute plans here. Hopefully you saw that announcement, and this is not too big of a surprise here. I was sick all yesterday, still not doing great today, although the meds are keeping me upright at least. I slept like all of yesterday. Was still fevery last night, so probably better not to come and share all those germs with you folks. So I'll be here still on Twitch for the lecture, and then for the lab, I was going to open up a Zoom room. So it's probably a little easier to hop in and answer questions if you folks have questions about that. Excuse me. So yeah, that's the plan. So we're going to get into chapter 4 today, which is awesome. So we're officially into week 4. Wow, that semester's flying by already. So week 4, we're going to get into branching today and work on our lab. We're going to practice a little bit more with some of the types, and we'll start working on some branching as well. And we'll have, if you have any questions about Project Zero, you can let me know about that as well. Sorry, this cat here wants to play. They're still very much kittens at 5.5 months old. So they like to bother me while I'm down in my office here. Okay, so any other thoughts, questions, concerns before we get going? I'll fire up PyCharm here, and we can start a new project. Yeah, hi Stella. This one's Stella. Hi there, baby. And that was Screech earlier. I guess they're both going to be bothering me here. Okay, so let me start. No, you can't be on the keyboard, baby. Can't be on the keyboard. File new project. So it's in my course repository, which is great. So this is week 4. This is branching. And now branching is fantastic. We start to have the ability here now to make our code do different things depending on values of our variables, which is awesome. So a real common thing that we might think about for branching in the real world here. So if we say, hey, what's the weather today? And I've got it here on my computer. Look, it's like 21 degrees Celsius, which is nice. That's right around, what, 70 or so Fahrenheit, maybe 72 Fahrenheit or so. So hang on, what's the math here? I'm trying to get off of the terrible Fahrenheit and imperial measurement system and do some more sane systems like Celsius and metric. But you know, we're working on it here. So 21 times 9 divided by 5 plus 32. Oh, okay, so just at 70. Okay, I was off a little bit here. So 21 is just about 70. Just about 70 degrees. So if you look at the weather and you say, hey, it's about 70 degrees, you think in your head, okay, if it's, 65 to 70 degrees and sunny, I don't need to bring a jacket. If it's not, if it's less than that, then I might want to bring my jacket. And maybe in Michigan we usually say, like, if it's less than 60, maybe start bringing a jacket, but there's some sort of range here. And we can do that same sort of decision making in our code with branches. So we can say, hey, here's the temp here will be an int of an input. Generally, people, when you ask them the temperature, give you whole numbers. I don't think you probably need floats when you deal with that sort of thing. What's the temperature outside? And then we can say, okay, so if the temp is now less than, we'll say 60, we'll print bring a jacket. Okay, this is our decision making. This is our branch here. So we can say if, and then this is known as a Boolean expression. So a Boolean expression is either true or false. Right? There's nothing else. It is either true or it's false. There's no in between. There's no middle road here. So either it's true and this block of code will run, or it's false and this block of code does not run. So if it's true, all of the code after this colon that is indented will run. So the indentation here in Python tells Python that this code belongs if this is true. And anything in here, I don't know what else do we want to say, and don't wear Crocs or something. I love wearing Crocs all the time, but if it gets too cold, your feet start to get cold. So anything that's indented here, we'll say belongs to this if expression, and it will run. If you want to have something happen if it's not true, we have an else. So else is if it's not true, then we can say print, I don't know, bring your sunscreen, or don't forget sunscreen or something. Forget sunscreen. right? So if it's not less than 60, meaning it must be greater than or equal to 60, we'll say, don't forget your sunscreen. So we can have two different things happen when our code runs, depending on what that value is. So what's the temperature outside? We'll say it is 70. It says, don't forget the sunscreen, because this was not true, so none of this code runs, which is awesome. So now our code can do different things depending on what those values are. And we'll run it again, right? Let's see if it's 55. We'll say, bring a jacket, don't wear Crocs. Right? This code runs, but the else does not. So with an if and an else, you get this mutually exclusive idea that this one or this one will run, but never both. Right? So if and else are paired, so one and only one of those will run when we get to it, which is awesome. So this idea that I can make my code essentially make choices or go down different branches, go down different paths as they run is awesome. Then once you stop indenting, we get back to this runs all the time, no matter what. Right, so this doesn't belong to either the if or the else. See, it's no longer indented. We're back to the regular code. So that'll run no matter if it's true or if it's false. If it's 55, it'll still run. Or if we run it again and we say it is 75, it'll still run no matter what. Because once this if else section here is done, we'll get back and everything else will run. So this is really handy because depending on what the value of something is, we can do different things. And now you might even want to have more choices here. So some similar choices here. Let's say, how about we get a score is an int of an input. Please enter your score 0 to 100 here. And then I can say, hey, if the score is greater than or equal to 70, we'll say pass. If it's not, then I'll print fail. Right. So if 70 and up, we'll consider passing. Other than that, it's a fail. This is a pretty quick, you go this way, pass, you go this way, or you fail. Right? One or the other will happen here. But if you wanted to be more specific here, let's say we got a 95 here, right, as pass. If you wanted to do some more letter grades and be specific here, we can start to have more of these branches, right? Because just having one, this choice or this choice doesn't always give us exactly what we need. Sometimes, if the temperature is going to be less than 30, you probably want to bring your winter coat. Right? And again, these are the terrible Fahrenheit temperatures because that's what most people are familiar with. But we can give other options. So you can have more than one branch in here rather than just an if and an else if you want. So we could say, hey, if the score is greater than or equal to 90, we'll print A. And really that's like 93 or something, right? But then if you want another branch, you say, okay, if this isn't true, you say else if or elif score is greater than or equal to 80, we'll print that's a B. Elif score is greater than or equal to 70, we'll print a C. Else we'll print a fail. So now we have a couple different branches that could happen. And because these are all, this is known as a chain, they're all linked together, they're chained together here, one and only one of these will run. They're still mutually exclusive. This one here. So still mutually exclusive. One and only one will run, right? If it's true, this one will run, and then everything else gets ignored because this is similar to saying else if, else if, else if. It saves you a little bit of typing because you could say else, and then inside of that else you could have this if, and then it just gets really messy because then you'd have an else here, and then inside of that else you'd have an if, and like this is just really ugly here, which is not ideal. And then having this else fail would have to be here, and that would also have to be part of the other one, and it's not good here. We don't want to have to do any of that nonsense. So the else if combination, the elifs here, make life a lot easier for us and kind of group all these things together. But we still get that cool mutual exclusiveness that one and only one of them will run here. So we can do more than one branch at a time and say, okay, let's see, do you fit in this path, or do you fit in this path, do you fit in this path, do you fit in that path, and on and on and on and on as we go. Now, other times we might not be able to have just a single expression here. So we also might want to then ask if it's raining out. So we'll say it's raining is an input of is it raining? And now anytime you're prompting people, I would recommend you prompt them and say, hey, you should enter yes or no. You're not guaranteed to get a yes or no here, but you're more likely to get a yes or no if you tell them, please enter a yes or no. Right, so we'll ask them if it's yes or no. So if it is cold and raining, we might want to do something that's different than if it's just cold and not raining. Right? So we could have some checks, and we can have what's known as a nested if here. So I can say, okay, if raining is equal to yes, then I don't need to tell them anything about sunscreen, right? Because it's raining, they're not going to need some sunscreen here. But then we'll also want to tell them that they should bring a jacket, or they should bring an umbrella, sorry. So we should print bring an umbrella. And then if it's cold, they should bring the jacket and don't wear Crocs. And if it's not cold, well, really that's it. It's, so not too much else has to happen here. And then if it's not raining, right? If it's not raining, do we still want to check the temperature? Maybe. So maybe then if we say, hey, if it's less than 50, we should bring the jacket. Because if it's not raining, you can probably deal with no jacket. Otherwise, right? To go a little colder. If it's sunny out, you probably don't need the jacket at 60. Maybe you need it at 50. So you can have this idea. You can have more checks, more branches inside of other branches here, and start having logic inside of logic, and say, okay, does this happen inside of here or not? Okay. It can get a little funky here. So we just need to stop and look at each one of these individually and say, okay, if this is true, this code will run. So we're always going to bring an umbrella if it's raining. And then if it's chilly, we're going to bring the jacket and don't wear Crocs. If it's not raining, then we'll tell them to bring a jacket and don't wear Crocs only if it's even colder than the previous check. Because, cold and rainy is different than sunny and cold. Right? Different clothes for different weather. And so we can put those inside of the other ones. Okay, this is yelling at me because there's too much space there. There we go. It likes 2 spaces for some reason. But we can have this sort of logic here, which is fun. Now, you can do other checks as well here, where we can start combining some of these things in a single expression. And this is where it starts to get pretty interesting here. So we can start combining statements. So maybe we want to have, let's see, so this was a score here, and then maybe let's look at an average here. So we've got single score, and let's get an average here. So we'll say an average, an int of an input of enter the average score. And we'll say if you did better than the average, we'll just call that an A. Right? So we can say if your score is greater than the average, we'll print it's an A. Else if, now I want to see if your score is within a certain range here. So with Python, you can do some cool things. So we can say, how about average minus 10. We're going to do this in parentheses to force that order of operations here. Average minus 10 is less than the score, which is less than the average plus 10. So if it's within 10 of the average here, we're always going to be greater up here. So maybe we didn't want greater. How about we'll say if it's 10 more than the average, or greater than the average plus 10. How about that? It's an A. Right? And again, unlike the parentheses, it's probably not needed here because we're going to evaluate that first, but never hurts to add the parentheses. So now this is going to check within a range, right? Are we greater than the average minus 10, and are we less than the average plus 10, right? Are we in between these ones here? And we could probably do the equal sign here, less than or equal to, and less than or equal to. So we can fit in here. So we'll say, hey, okay, if you're within 10 of the average, we'll say that's a B. Otherwise, we'll print it's just a C. Something, I don't know. We're just making up some stuff here. Right, so we can do ranges with numeric values here, which is fun. Okay. Now, let's ask people if they should be drinking more coffee. So we'll say, how about tired is an input of, are you tired? And again, yes or no is probably ideal here. And then Maybe we should ask them how many cups of coffee they had. So how much coffee have you had already is an int of an input. How much coffee, or how many cups, how many of coffee you had already, because we want to make sure we're being safe here, right? So now we can check. So we can say if tired is yes. Now I'm going to say, okay, if you're tired and you haven't had so much coffee to drink, you should drink more. So we're going to use this and keyword here to combine two different Boolean expressions into a single Boolean expression. So, and how much coffee you've had today is less than, how about less than 4 cups? So if you're tired and you've had less than 4 cups of coffee, we're going to print, drink another cup of coffee, right? Otherwise, we can print, you've already, I don't know, but if they're not tired, they don't need the coffee, or if they drank too much, they don't need it. We'll say drink some water. Okay, so we can use this and operator here to combine two Boolean expressions. So what you get here is kind of fun. This idea with an and here is both sides need to be true. So for the expression to be true, this needs to be true and this needs to be true. So when you go to McDonald's and you order a burger and they say, do you want a burger and fries? And like, do you want fries with that? Right? They're saying, do you want a burger and fries? You say no, because McDonald's fries are garbage. They're just gross. There's like no potato to them at all. You're just eating fried, like oil, essentially here. So I would never say yes to fries. So if they say, do you want a burger and fries? The answer is always no, because I don't want their nasty fries. They're awful. I don't know why people like them. They're not good. Go get some good curly fries somewhere. You'll be much happier with yourself. So for an and to be true, both sides need to be true. So this idea of these Boolean expressions, when we combine them here, we get true and true is true. We get true and false is false. We get false and true is also false. And of course, false and false is still false. So the only time you're going to get a true result is if you and two true results together. Right? Do you want a burger and fries? If you don't want the burger, you say no. If you don't want the fries, you say no. If you want a burger and you want fries, you say yes, because both those sides are true. Okay. Now, a similar way of combining expressions here is an or. An or is either side is true here. So if you get true or true, the whole thing is true. If you have true or false, the whole thing is still true. If you have false or true, the whole thing is still true. And only if you have false or false, the whole thing is false. So with ors, if either side is true, the whole thing is true. But if neither side is true, then the whole thing is false with ors. So if you go to McDonald's and they say, hey, do you want a burger or coffee? I'm going to say yes. And then they're going to just look at me like expecting me to tell them which one it was, but I answered their question. Now, I don't recommend you do this. The poor folks at McDonald's don't get paid enough to deal with your nonsense. Or if they say, hey, do you want a Coke or a coffee? And you say yes, they're just going to stare at you, right? And I'm like, well, which one do you want to drink, right? The non-programmer here, if you say, do you want this or this, expects you to tell them which one of those you want. But for programmers, when someone says or, right, you know the answer is either true or false. Yes, I do want that, or no, I don't. So, if they offered a Coke Zero, I'd say yes. Or the coffee, I'm always going to say yes to coffee because you can't have enough coffee. Okay, yes, there is a limit how much coffee you can have, or that's recommended for you, but it takes a while to get to that limit. So I'm only on, this is cup number 3, but these are like double-sized cups, so probably cup number 6, essentially, if you were to count them as like normal-sized cups. But I need something to get me going here because it's been rough. So you can and you can or things together. And then there's also, so these are known as Boolean operators, right? This will operate on Boolean expressions and combine them. So tired equals yes, and how much coffee you've had already is less than 4. If either one of these is false, then the whole thing is false. So if you're not tired, or you've had 4 or more cups of coffee, the whole thing will be false, and we'll tell you to go drink some water. Here. Oh my goodness, I misspelled coffee. That's not allowed. I'll bump that down a line. Make that fit on the screen a little better here. Okay, so in terms of Boolean operators, we can AND things, we can OR things. There's also a NOT operator. This is the opposite, right? So not true is false, and not false is true. So this one makes a lot of sense, right? It just flips it, it reverses, right? Not true. If it's not true, it must be false, and if it's not false, it must be true, right? So it's just the opposite here. So we can use these in any sort of combinations here to get some singular Boolean expression here. So right now I have two different Boolean expressions. I'm combining them into one to figure out if this if block should run. So if it's true, I'll tell you to drink another cup of coffee. If it's not true, I'll just tell you to go drink some water. Okay, so that kind of idea here with these expressions. So we've got lots of ways to use these expressions to create the branches to say, okay, our code should do this, or it should do this, or it should do this, or it should do this way. And really, we could write this any sort of way that we want here. So if you wanted to, we could say, hey, if tired is yes, then we could say if how much coffee is less than 4, we could print drink another cup of coffee. Else we could print drink some water. Oops, my goodness, that's not what I wanted. Print drink some water. And then the else here, print drink some water. Right? So this is the same thing here. We're going to get the same result. If this is true and this is true, we'll get this one. Otherwise, we'll get this one here. Yeah, no interrupting at all. Quixotic. Yep, so a Boolean is something that is true or false. So this idea of a Boolean is true or false. So if something equals something else, it either will, and yes, it's true, or it won't, no, it's false. Right? So Python even has built-in Booleans. You have a true word here. You can use the capital T, true, yep, or the capital F, false here. Those are the built-in Booleans. So usually we'll use a Boolean expression, which is just some code that gives you a Boolean result. If you're just saying if true, do some code, you don't need the if true because you know it's always true. So generally we use these expressions that will, depending on what the user's entered or depending on the value of something, whatever happens to be here, we'll change it up. Oh, look at that, 24 and sunny now. Nice. So we have increased our temperature now. So let's see, that's 3 degrees Celsius, so about like 75 now, right? Coding formulas that help generate the if-then statements. Correct. I'm not sure what you mean by the formulas, but so we're trying to say if you need your code to make decisions, if your code should do something if this is the case, and do something else if that's the case, we can use these if-else expressions. So this allows our code to essentially make those decisions for us. Because previously, the only thing that would happen is it would run the top line and run the next line and run the next line and run the next line, next line, next line, next line, on and on and on and on. And it wouldn't do anything. So if we come back here and we look at our assignment here, this project 0, right? If they don't have enough money, we tell them no. Well, this is how we can check for that. We can say, okay, how much money do they have? And if that is more than the cost of the item, or really the cost of the item times the quantity, right? We can do that arithmetic and then tell them yes or no, because we can compare and say, hey, if the amount of money you have is greater than or equal to the amount that it was going to cost here, great. Okay. If we don't have the quantity, also we have to do something here. So we can do the same sort of expression. We can go get the value from our quantity from our dictionary here, and we can tell them no. Oh, gotcha. Yeah, a formula like an Excel. Yeah, like a formula. Sure. Yeah, we're just putting that all in here. Yep, so we can make those decisions in here. Okay, so we can have more than one branch. We can combine things. So you can go crazy with these if you want here. So this is same as above. So you can see why using the and here, this logical operator here, right? Because we're combining. Sorry, it's not a Boolean, a logical operator. I think I said Boolean operator. I'm a little out of it. The logical operator combines two Boolean expressions here. saves us a little time here. And then it's kind of easy to read as well. You're saying, okay, this and this. It works out really nicely here. Rather than, okay, if this is true, then I have to go find another one. And then really we have the same line of code here twice, which is not good. The general rule of thumb is if you have the same code twice, you should feel bad about yourself. We haven't really figured out how to do that yet, so don't feel too bad about it here. And we'll learn ways to reduce that duplicate code as we go. All right, we're still learning our basics here. So, but once we've learned the basics, there's pretty much no excuse to have duplicate code. All right, so we're looking at how we can make these decisions based on what the values are. We can do these branches here. Let's see, what else do we have in here then? Branches, values, ranges, logical operators, ranges with gaps, yep. Features, yep. Comparing data types. So this can get a little tricky here when we start comparing data types. So a lot of times when we're saying, hey, does this equal a particular value here? Because everything comes in as strings here. Right, we've got it all as strings. So if we're not careful here and I don't do the right conversions, right, like how much coffee have I already had, if I forget to do the int thing here, and we're going to try and compare less than 4. All right, so temperature 24 degrees Celsius. Oh, it's not doing Celsius. No, it's not raining. Score, we'll say 90. Great. Passing A, average score 90. Sure. Retired. Yes, we're tired. How many cups of coffee have we had today? Let's do 3 cups of coffee. We get, type error. The less than not supported between string and int. You can't compare is a string less than an int. Right, so Python's going to crash on us here. It's going to say, can't do that. And it's telling us here at line 47 in our code, it copies the line in for us, which is nice in case we don't want to go find it. But this little link here, will take us right to that line. We can see, oh, hey, we compared a string to an integer. And we'll look back at our code and say, oh, wait, I forgot to do that conversion here for how much coffee. So I'll go undo my edits here and put that back to an integer. And now it should work for me. Okay, so yeah, we'll say 75. It's raining, no. Score is 100. Sure, why not? Average score is 100. We're tired, yes. Now I'm going to say 3 because I'm counting mugs instead of cups here. So it says drink another cup of coffee. Notice I get that twice because we have it twice, right? We have it once with the combined with our logical operator, and we have it once here without the logical operator. Right, so logical operator combines Boolean expressions. So I'll try and add these notes for you here. I tend not to have comments in here. I apologize. Please just shout at me if they're useful here for that sort of thing. So you can and, you can or, and you can not. Those are our common operators here. Okay. Now there's some other really cool operators here, which is nice. There's a membership operator, which is super handy. So if I make, let's say we have a list of classes, maybe. Is going to be CIS 1501 and CIS 200. So these are the classes I'm teaching this semester here. So I can ask what class you're taking. So we'll say this is the class you are taking is an input. What class are you taking? And there's probably a space here. I'll put spaces in, and it's going to matter, but that's fine. So I'm going to see if you're in my class, essentially, right? Are you in my class? And turns out in Python, that operator is in. So I can say, if the class you are taking is in my classes list, print, you are in Eric's class. Thanks so much for following along, my friend. Glad to have you here. Otherwise, that's so sad you aren't in Eric's class. Right. So this in is the membership operator. Membership operator. In, right? If this value is in this list, it'll be true, right? Is the value in the list? Or really, I should say in the collection. So it works for any sort of collection. It doesn't have to explicitly be lists. Remember, we have lists, we have sets, we have tuples. It even works with dictionaries. We'll get to that in a minute here, how it works with that. And then remember, strings are technically sequence types, which are collections. So you can even use that with strings, which is really fun here as well. Okay. So we can ask and say, hey, what class are you in? Oh, that's right. Let me stop. I can do it this way, right? And just run this selected code. I've got to remember to do that all the time. Okay, what class are you taking? So how about we say we're taking CIS 1501? You're in Eric's class. Huzzah! You're in the class. Right? That you are in this collection. Okay? Now, let's say we wanted to make this, say, a dictionary here. So I'm going to say, here's the key. The associated value is going to be a list of students, maybe. So here's the key, colon, the list of students here. And then we'll say, okay, if that class is in it here, let's ask for your name is an input of, please enter your name, and then I'm going to take my classes key of the class you are taking, which will give me the value associated with that, right? Or with the dictionary, we get the associated value, which will be this list here. And then if you have a list, I can append your name. So I'm going to add your name to my class list because you're taking my class. So when I'm done here, I'm going to print my classes dictionary here. Okay, so this works with dictionaries. Now with dictionaries, you have to be careful. Dictionaries, it only checks the keys. So when you ask if something is in a dictionary, it's only checking the keys, not the associated values. So, that is an important distinction here. Okay, so let's give this bit of code a run here. Oops, come on, highlight. And execute. Okay, so let's say CIS 1501, and what's your name? I'll say Eric, and I will see my dictionary when it gets printed out here. The key of CIS 1501 has an associated value of a list with Eric, and then CIS 200 has an empty list. We haven't added anyone to it yet. Okay, so we can get the values associated with that dictionary if you're in that dictionary. Okay, now the other thing we could do if we wanted here, so maybe we'll say, hey, maybe Eric should teach that class. Good news, Eric will teach that class. So I'm going to take my classes, key of the class you're taking, and associate a new list with your name in it. Oh, I didn't ask for name. We should ask for name probably here, right? Why not? Thanks so much for following along. So in this case now, if I have that key already in the dictionary, I'll add you to it. If I don't have that key in the dictionary, I will go add it to the dictionary. Remember, this is the dictionary. The key doesn't exist. It adds the item with the associated value. Associated value. I love spell check. Spell check is my best friend because I was never a good speller, which is okay. You don't have to be a good speller. Okay, so whether or not I was teaching that class, I've now added it to that list. So the in membership operator works great with dictionaries. It checks for the key, which then we can go and add it or not. Excuse me. All right, so we can go through and figure out whether or not we need to add those particular values here. We'll go run these ones again. So how about we have a different class? How about like CIS 350? I haven't taught that one yet, but we'll get there. And Eric, maybe one of these semesters I might teach it. We'll see. They've generally got some good people teaching those ones, and don't need me for that. So works out okay. We'll see it added that new class to the dictionary, which is awesome. This making sense so far? I know it's a lot of new stuff. It's okay. Working with if and else if, making those chains, doing these Boolean operators. There's some good stuff we're getting into here. Let's see, the membership operator is great. Order of evaluation, yep. The indentation is great. The conditional expression. So some people love this conditional expression. I'm not the biggest fan of it here, but it's okay. It totally works. So it's a bit of a shortcut. So some people think it's a lot of work to do. Let's maybe come up here where we did this pass fail. So doing this here was a little long here, right? Having to have if, else, and all this sort of thing here. So what you can do with the conditional expression is you can simplify a basic if else. If all it is one if and one else, and you're just assigning a value, we could do something. So we have a score variable here, but if I wanted to change like your, how about the score as text maybe, we can say equals, and then I'll say score greater than 70, question, colon, pass, question mark, fail. No, I'm backwards. I think it's this way. Nope. Oh my goodness. Don't I have score? All right, friends, I'm misremembering the syntax. Okay, that's all right. We'll go look at it here. We'll cheat. Yeah, if. Oh, I forgot the if. That's right. If greater than 70, colon, pass, else. There we go. Else. No? Oh my goodness. Where's my syntax? If condition. Oh, I'm backwards. There we go. There we go. So I don't like this syntax. This is confusing for a while. So you write it backwards here. So we're saying, okay, it equals a value if this is true. Otherwise, it equals this value. Right? It's the same as saying my if score is greater than 70, score as text equals pass, else score as text equals fail. And you can see why some people like writing this. You know, 1 line of code versus 4 here does the same thing. The syntax is just really funny here. So you have the if else still, but the value it equals starts over here, and then the else is over here. I find them awkward. Some people, probably a lot of people who like and write Python a lot will use this because they're familiar with it. It's confusing, especially as someone new to programming. The rules are really awkward. The syntax is weird here. Why is it? It feels backwards, but you'll see this a lot, especially if you start Googling things online. People love using these conditional expressions, and they're great. They are powerful. You can do some cool things with them. As we get later on in the semester, we'll see a little more with it. And then next semester, if you do continue on in 2001, we use a similar idea here. When we start talking more about lists, there's some fancy things you can do with lists and one-liners, which are really cool. It's all just about being a shortcut, making it a little faster to type. And if you've seen it enough, you can probably figure out, okay, if your score is greater than 70, you get this one. Otherwise, you get this one. But again, I'm not going to ask you to write these most of the time. My general rule of thumb is if the code works, that's great. Any way you want to go about writing it's fantastic here, because programming is as much of an art as it is a science, right? There's an art to how do we write the code to make the computer go beep boop bop, right? In next semester, specifically, we'll talk more about the science of it. How do we make sure it's fast and efficient and those sorts of things? But really, we just want to get the job done. That's the goal here, so we can make the computer do the things we want it to do. Doing it, quote unquote, right or fast or efficiently, that is a problem and that is important. But for our purposes, and especially your first semester programming, we don't care if it's fast or slow, right? We just want it to get the job done, right? We can start looking at that. We can start learning about those things later on as we go and getting better. We just want to figure out, can we make it work first? Okay, that's kind of the conditional here. All right, there we go. We had to cheat and go back to the iBooks. No one is going to remember all of it here, so don't feel too bad. All right, then we got some labs going on. So this was pretty good, actually. We definitely need to do some more practice with these. We'll spend more time. Let's see. Let's go back to, and hopefully now you're seeing where these if-else expressions can go in here, right? When we start looking at some of these things here for that assignment. Let me go back to our schedule. I think we're doing pretty good on the schedule, which is awesome here. Let's see. So for branching, yeah. So next week we'll get into loops. That's good. I don't think need to get ahead on loops. I think we'll have enough time, and with the project review, I think we'll be okay with loops there. Let's see how well it goes. So for lab today, then we're going to finish out practicing with our dictionaries, and then work on some branches here, and then maybe that'll work. So maybe we can shift this a little bit here and start doing new stuff Wednesday, Monday, and then the lab can be that new stuff. That might work for us here. So if we pick up loops on Wednesday, then we can do Wednesday, Monday for loops, and then do the lab on loops. And that way we're not having labs kind of in the middle of content, and then maybe that'll work out well. We'll give that a try and see. I can rewrite the schedule if you want, but then it's going to look a little messy with like 2 sections each time. But I think that'll be okay. We'll practice branching. It's okay if it feels funny. We've got all those Xylab exercises to get you some basic practice with it here, which is good. I like these because they give you lots of practice opportunities, and they tell you if you're doing it right or wrong, which is really nice. So I turned them all on for this one. So 6 little small Xylabs here, working through them, doing some practice with these conditionals. It's just pretty good. Yeah, actually, I don't have too much more. That's awesome. So I guess it's probably easier to get through stuff faster if no one's asking me questions, because I miss seeing you folks in person there, but you don't want me coughing and sneezing all over you any more than I want you coughing and sneezing all over me. So I think we're pretty good for now. We'll pick it up at 2 o'clock. Again, I posted that Zoom link out here in Canvas. You should have the link for it there. If you don't see it, let me know. You don't need to hop on if you don't want to. You're welcome to give it a try and pop on if you do have questions, but whatever works best for you. Sorry, I'm not there in person in the lab, but the room should still be open for you if you want to use the computers there. Or you can just do it from your laptops, whatever works best for you. And I'll be around that time to help. We can do some screen sharing on the labs, and that should work out pretty well. Excuse me. Any other thoughts, questions, or concerns, folks? Anybody in chat? How you feeling so far? I know it's a lot of new stuff, and that's okay. We're going to practice it. That's why we have all this practice time to work on these. Okay. All right. Cool. So why don't we end? We'll end a little early, and then hopefully you can go check out those boat races. Right. I think that that was happening this afternoon, right, at the Chancellor's Pond there. So go take a look at the boat races. It's usually a good time, cheering people on, hoping they don't sink. And you folks take care. And so I should be back Wednesday. I'm doing a lot better, although I've been pounding Tylenol and ibuprofen to keep the fever down. So I'll check tomorrow, and if I'm fever free tomorrow, I'll be fine to come to campus. Did one COVID test yesterday. I'll do another one tonight and see. I don't think it's COVID. I don't have a lot of the symptoms. So I mean, we'll see. I'll try and be careful here. Make sure I don't get you folks sick. So hopefully it was something else, and we'll see how it goes. So, all right. If you have any questions, let me know. I'll be around. You can email me. You can find me on Discord, text, call, whatever works best. If not, I'll see you on Zoom for the lab if you're up for it. You folks take care. Thanks. Thanks, Jay.